Tsinghua. Mr. Zhu Bai, I guess you know the topic quite well. Please.
Hello, everyone. I'm honored to introduce this new and also major future internet research project supported by China 863 program to you. This is Professor Jun Bi from Tsinghua University. I'm also serving as the leader of this project. Here's the outline. First, I will briefly introduce the project overview, then update the latest research progress, finally the conclusion. Okay, the overview. Here is the basic information of this project. The official name is FINE, Future Internet Architecture and Innovation Environment. This project is supported by China Ministry of Science and Technology High-Tech Research and Development Program. It was officially approved last year and funded this year. From this list of project members, you can see it's not only Tsinghua University's research. You can see we have members nationwide. For universities and the National Research Institute, Tsinghua University is the leader of this project, and we also have China Academy of Science, BUPT, Southeast University, Peking University, China Academy of Telecommunication Research, and other universities and research institutes joined. For the service providers, we have CERNET, China Education and Research Network, and China Mobile, and also some company in broadcasting service providers. And nearly all domestic equipment vendors, including ZTE, X3C, Huawei, Huijie, Digital China Networks, joined this project. Here are the project goals. First, we need to design the architecture to achieve the open environment, experimental environment for future internet research. And we need to deliver the new devices, new software, and we need to build up a experimental platform with interconnected networks, including university campus networks and carrier networks. This is a platform for future internet research, so we need to at least support some host-IP or non-IP network architecture. For example, the content-centric network like NDN or PTDN, which is the new architecture proposed by China Academy of Telecom Research, ITUT, which is trying to combine the connection-oriented network and the connection-based network architecture. And you know China is strong in IPv6, so we also want to support the experiments of some new IPv6 protocols like the intra-domain or inter-domain IPv6 source address validation to enhance the network security, the LNP, which is the IPv6 ID locator separation protocol for mobile networking, and also some new routing protocol like two-dimensional routing. So those are applications of this platform. Here's the design concept. This picture shows a traditional experimental network. Those big blocks denotes the equipment box. So each equipment vendor, they have their own operating system inside and also specific hardware. If you are a designer, you need to work with the equipment vendor to implement your protocol and the yellow box inside the box. So you can tell it is a closed procedure and will take a long time for innovation. So in our project, we have a unified network operating system sitting on top of those open devices. Then your new application, then your innovation can be applications sitting on top of this network operating system by making use of the programming API. In this project, we want to promote the innovation in our universities, so we may support hundreds, even thousands of applications. So the hardware resource might be not enough. So we have a new layer called virtual application platform. So here, the designer, they put their virtualized resources, and this layer will mapping the virtualized resource to the physical resources. The last opening is the open data abstractions. In this platform, we want to be compatible with any new type of open devices. So here, different colors denotes different type of open devices. For example, OpenFlow is one kind of open data abstraction. Therefore, we have a fun architecture design like this picture. This is a 4-layer architecture. The bottom layer is open devices. Here we have data plan abstraction, DPA, number 1, number 2, to number n. As I mentioned, OpenFlow can be one kind of DPA. We also have other new type of DPAs and this later. So those open devices will provide a local view API for programming of the upper layer, which is the NOS, network operating system layer. And the NOS layer will gather the information of the whole network and generate the global but typical view API. We provided it for upper layer, which is VCP, Virtual Cloud Platform layer. This VCP layer will translate those physical resources into virtualized resources and provide virtual view API to the top layer, which are the new architecture or new protocol. So those APPs, they can program their functions by making use of this logical view API, then communicate with the NOS layer and eventually control those open devices. In our opinion, our test bed needs to support a large scale, so we will have many different domains. So in our opinion, the application in domain 1 cannot directly control the open devices in another domain. So we need those modules, we call it IDN, inter-domain integration. So those inter-domain controls can be negotiated between different domains. Therefore, we designed an interface called bridge, which is the west-east bridge, so that for the applications in different domains can talk to each other by using this interface. According to this fun architecture, we have this project architecture. We have 5 sub-project groups led by different universities. Group number 5 is the core part led by Tsinghua University. So here we design the data plan abstractions, we design the implement network operating system called the Tunos, which is Tsinghua University network operating system. We design implement the VCP. And to demonstrate this platform, we also take typical open network devices and typical new architecture and new protocols and examples. And group number 1 led by ICT of China Academy of Science, working on a programmable virtualization model. The early version is called PERF, I think it mentioned earlier by the speaker. And group number 2, led by BUPT, the working on the future network measurement and management system. Group number 3 is by Southeast University. They design special open devices and also they design a new architecture, which is the core architecture for content distribution. And group number 4 is by Peking University. Similar like group number 3, they also design open content router and design the content addressing protocol. We are going to build a nationwide test bed, including the education network, research institutes in telecom, and broadcasting areas. With this platform, we will take new network architectures and new IP protocols and the demonstration. We also have inter-domain applications. Eventually, we will provide a platform like this. If you are a designer A or you are a programmer B or tester C, you can use our file portal to book your own experimental resources, including topology and other resources. Then this virtualization platform system will map your requirements into physical resources and control the tuners in different domains and eventually control the different types of open devices to perform your requirements. That's the overview. Now it's the latest research progress. For the fund architecture, we were invited to present with the Open Networking Summit last year and also the Internet 2 and API meeting this year. We are also invited to join the Open Networking Foundation as a research associate on open networking architecture. For the data plan abstractions, so far we designed 3 sorts of data plan abstractions, which are determined DPA, assembled DPA, and programmable DPA. The determined DPA means if the data plan of the new architecture or new protocol is determined already. For example, if you are working on the new control protocol of IP architecture, then you can use the extension of OpenFlow as the data plan. Or if you are working on content-centric network, then we designed a new data plan abstraction called the content channel to support your data plan. The assembled DPA means if your data plan is not fixed yet, you still need to adjust or change it during your requirements. Then we provide those design modules like people looking up as building blocks for your data plan. Then you can assemble those building blocks as your new data plan for your requirements. If those modules is not enough for you, your data plan is quite special, then we still have programmable DPI. Here we have a language that you can program everything. And based on the design of different types of data plan abstractions, working with our member universities and equipment vendors, right now we have delivered some prototype of different data plan abstractions. QNOS. Right now we finished the design of QNOS architecture and some key modules of QNOS. Basically, QNOS will manage the resource in the whole network, especially when the resource hardware is not enough and limited. Then we can schedule the resource between the resource between the server side and the hardware device side. This concept was successfully demonstrated in this year's Open Networking Summit. So here we use the real topology, the real traffic of Tsinghua campus network. Here you can see we schedule the most popular forwarding resources into the hardware to make sure those additional flows can be forwarded in the fast path by hardware. And those long tail mass flow or end flows can be handled by software. And we also support different applications, so we also balance the fairness among different applications to achieve the balance between the efficiency and the open and the fairness. For the application, even though this is an ongoing project, but we already finished some applications and small scale test bed, especially for IPv6, we are doing that. So, for example, in Infocom 2.12, we successfully demonstrated the intro-AX IPv6 cross-address validation, which is the new architecture and protocols to enhance the network security with the open routers. And just last week, in the top Academia Conference CCOM 2013, our demonstration was accepted. This is a demonstration on our inter-domain mechanism. It's work collaborating with Stanford University and OpenLab. I think this demonstration is effective. And the next month, we're going to battle with the Internet to the inter-domain mechanism between Surnet and Internet in 2013. And I heard that the SearchNet, which is the education network in the Netherlands, also interested to join. For details, you can check our latest application. Okay, finally, FUN is the very first research and development project in China to support a nationwide environment for future national innovation. And in this project, we proposed and designed new FUN architecture, multiple discipline abstractions and open devices, and prototypes from software like mouse, wiki, and value system, and selected applications starting with small scale testing. And we will keep working. Thank you.
Thank you, Mr. Junbi, for the excellent presentation. Now time is good for lunch. So we go for lunch and come back at 1:30 to resume the panel discussion, especially how to participate in EU projects together with the help of the ECL EU panel partners. So have a good lunch. I think somebody will show you where it is, and back at 1:30. Thank you.